Okay, so welcome to the session, everybody. I hope you're doing well. Good morning to everybody. So today we are going to be working on part 3 of chapter 6. So we did part 1 and 2 on Wednesday. Today we're just going to focus on part 3, which is where we're getting into moles, mass, particles, ions, and molecules. So for this session, since it's an alternative SI session, you cannot turn on your audio, unfortunately, or video, because we are recording it and then posting it on YouTube. If I do let you guys use your audio and video, we will have to take consent from everybody, and that's just a lot of work. So we're just gonna stick to this method. If you have any questions, if you're answering my questions, we'll just use chat, okay? So today we're going to work on 6 word problems, like I mentioned here. And then just a reminder that my next session is on Wednesday from 2 to 3:30. Other than what's mentioned on the agenda, is there anything you would like to go over? Okay, so if you do come up with something, you want to maybe go back to part 1 or 2, I don't want to practice more or formulas or anything, just let me know in the chat later on. But for the icebreaker today, this is our icebreaker. So for part 3, we are doing a lot of conversions. Okay, so I get in the chat that we should work on balancing equations. Okay, we'll work on those for sure towards the end. So for the icebreaker today, we are going to kind of explain how we convert from mass to moles, from moles to atoms/particles, and then vice versa, basically from atoms to moles and moles to mass. So just look at the question, try to process what the question is asking, and then try to attempt it and put the answer in the chat. Like basically what I'm implying is like, what do you need to go from your mass to moles kind of things, or moles to atoms? So I got an answer in the chat. So for mass to moles, we have molar mass, and then from moles to atoms, we have Avogadro's number. So does everybody agree with this answer? Let's hear for like 3 more people. Okay, sounds good. So everybody is in an agreement. So when we convert from mass to moles, we are using the molar mass. And then from moles to atoms or particles, we are using the Avogadro's number. Okay, so using molar mass to convert from mass to moles. Yes. So vice versa for the second portion, right? We just need the same thing, but the only slight variation is that for one, we multiply, for the other one, we divide it, right? So if everybody's comfortable with this, what is the Avogadro's number? Mm-hmm. 6.02 multiplied by 10 to the power of 23rd. Okay, so this is our Avogadro's number, okay? And now, again, here it's the vice versa. Oh, never mind. We need the Avogadro's. And here we need molar mass. Okay, and then what are the units? How do we write mass, moles, and atoms? The session is an hour long. Okay, so thank you, Austin. So we have grams over moles. And how do we write moles and atoms? Yeah, we just put MOL. The reason why I'm doing this, it might seem redundant, like why I'm asking this question. It's because in the past, what happens is that some students put MOL for molecules as well. For molecule, we write the whole name. So we're going to write the whole name molecules. For moles, we are just going to write MOL. And then for atoms, yeah, atoms is the same. Okay, sounds good. So this is kind of the main things you need to know for this session, basically. And then if you kind of understand this concept, what we have in the icebreaker, all of the problems should be reasonable. Okay, so the first problem here is converting from mass to moles right here. And then the question is asking how many moles of aluminum are in 15.29 grams. And then I gave you the mass of the aluminum already because I didn't want to like waste a lot of time trying to find the answer. So, but on the exam, you'll have to find it. Since we are already in chapter 6, you probably have a lot of practice on finding the molar mass. So let's try to do this problem, okay? So just take 2 minutes and then solve this problem and then put the answer in the chat. Yes. So the question is to find the molar mass. You just look at the mass of the element on the periodic table, right? Yes. You can try finding it on your periodic table as well. You should get the same-ish number. Oh, actually, there was someone in the lecture that needed help on putting the answers in the periodic table. So if you have any questions about that, let me know so I can kind of show you my calculator in the camera. Okay, so the question is the mass included in the calculation? So mass is just extra information that you need to solve the problem. Okay, so how about we do this problem together and then the rest you can do it on your own? Okay, sounds like three of you are kind of confused about that. Okay, so let's see. So the question is asking how many moles of aluminum are in 15.29 grams, right? So first we put 15.29 grams of aluminum, okay? So now we are going from mass to moles, right? So if you look here, we said we need the molar mass for that. And the molar mass is given. I just provided it to you. So now I'm going to put the grams here, which is 26 point, let's see, 982. I'm just going to round it. And then it's 1 mole. Basically, the conversion that you need is 1 mole of aluminum is 26.982 grams. Okay? The only thing you need to do is this. Okay? You cancel out the grams and then you cancel out the aluminums. Now on the top, you will have moles of aluminum. And then you'll just have to divide 15.29 divided by 26.982. So is this making sense to everybody? Yes, okay, sounds good. So if it does make sense, how about you give me the answer for this one? Okay, so we do have an answer. So I want at least 4 more to reply and then give me the answer. And then I want you to look at the significant figures that we have in the question and then give me the answer based on that. And then also give me the correct units that we are using. Okay, so I have 2. It's fine. Okay, so 2 more people. Okay, sounds good. So the answer is correct. It's 0.5667. Yes, 667. And then it's going to be moles of aluminum. Okay. Let's not, we could put, we could put moles of aluminum, but it won't necessarily make sense. So let's just put moles of aluminum like this. Okay. Because if we put this, that means we're dividing the moles by aluminum. Okay. So looks like everybody got this. So let's try the next problem. It's slightly different. Now we are going from mass to atoms. Okay, so this has actually 3 steps, but I want you guys to try and do it on your own, and then I will kind of give you more hints if you need them. Okay, I know we are doing this for like the first time, and this material could be kind of tricky because like high school chemistry doesn't go much into this problems unless you're in AP Chem, and I didn't take AP Chem either, so it's fine. So for this question, how many carbon atoms are in 28.48 grams? So now the focus is atoms. Before we were, oops, Before we were just trying to find moles, but now we're finding the atoms. And then I provided the mass of the carbon here already so that you can save some time. But there is one number that you need, and it's in the icebreaker, so you can look back to your notes. So I'm gonna just give you at least 4 minutes to do it. And then everybody, when you get the answer, just put it in the chat. Yes, so the question is, so we have to do more than one conversion for this? Yes. So basically, the hint is that you have to go from mass to moles and then moles to atoms, because we cannot directly go from mass to atoms. That's your hint. Okay, so we have one answer. Okay, so we have two answers. Let's hear from two more people. Okay, so 4 minutes up. So let's try to do this. Okay. Oops. So we start out with, sorry. So we start out with 28.48 grams of carbon, right? So kind of like we previously did. Oh, is it because of your internet that the Zoom is bugging out? I'll catch you up if something happens and then you get out of it. I'll help you catch up. Okay, So we start with 28.48 grams of carbon. So kind of like what we did previously, we use the molar mass to get the moles first, right? So here I can kind of add molar mass. So from mass to moles, we use the molar mass. So I added it here already. So 1 mole of carbon equals 12.0107 grams. And now that you have moles already, you're going to go to atoms. And then you need Avogadro's number for that, which is this, right? So you put that. So you put 1 mole of carbon, and then you put this answer, Avogadro's number, and then it is atoms, right? And then we want to make sure we are canceling everything out. So we have grams of carbon, and then grams of carbon, moles of carbon, moles of carbon. In the end, we will have only atoms of carbon, okay? So first we divide. So like if I'll just walk you through this. So what you will do is 28.48 divide by 12.0107. Then you get something like 2.37 something something. Then you're going to multiply that with Avogadro's number. So just put multiplication and then put parentheses. 6.02 multiplied by 10 to the power of 23, and then parentheses closed. Then you click enter, and then you will get 1.427 multiplied by 10 to the 24 atoms of carbon. Now, why am I putting 4 here? Is because 4 sig figs from the beginning. Okay. Okay. You solved your own question. So this is how I did it. Do you have any questions about this particular question? No problem. We'll just try to remember sig figs for next ones. Okay. So I just want to say, if you have any questions, like stop me right away, because from now on the problems are going to get a little more complex. Okay. So we'll move on to the next one. So now here we are converting atoms to mass. So we're going the opposite way. Give me just a second. I don't know how this tab started opening. Wait, give me a second. I'm sorry about that. I was just hearing random noises from my kitchen. Sorry about that. So, okay. So now we're going from atoms to mass. So now this is the opposite of what we just did, okay? So the steps are the same, but we are doing the opposite of what we were doing before. So take some time and do this problem on your own, and then we will go over it together. And I have already provided the mass for aluminum, so don't worry about going to your periodic table. So atoms to molecules and mass this time. Yes. But it's not molecules, it's actually moles. That's the difference. Molecules is just a little different entity. So we will have some molecule problems, and then I'll explain how to do them as well. So I can kind of write it for you like I did before. So it's going to be atoms, 2 moles, 2 atoms. Wait, to mass. Here you go. Good question though. Okay, so we have one answer ready. Okay, 2 answers. Again, if you're having trouble with the calculator, let me know. Okay, let's hear from one more person. Okay, so let's try to do this together. Okay, so like I said, this is the opposite, right? So now the question is, how many grams are in 8.03 multiplied by 10 to the 24 aluminum atoms? Okay, so we're gonna always put this information first when we're getting started, okay? So let's put this information here. And then we have aluminum's atoms, right? Okay. So first, we have to get rid of the atom. We have to convert atoms to moles, right? So what do we need to go from atoms to moles? There's a special number. Yep, Avogadro's number. So I'll just put it here. And then, so I just put that here. So I'm just going to put 1 mole of aluminum, right, is 6.02 multiplied by 10 to the power of 23 atoms. So I can kind of cancel out my atoms, right? Now I have gotten my moles. Okay, now I'm gonna go from moles to mass. So how do I go from moles to mass? What special number do I need? So I've given you the molar mass, right? This is what we need. Thank you. So what I'm going to do is put the moles here so I can cancel it out, right? Moles of aluminum. So 1 mole of aluminum is equal to 26.981539 grams. Okay, so I can cancel out the moles of aluminum from here and then get just the grams of aluminum. Okay, so is everybody clear on this before we do the calculation? 3 sig figs. So in the answer here, we're just going to put 360 grams of aluminum. Okay, is everybody clear on this problem? Any questions? Okay, so one yes. You can still show me your reactions, I can see it. You can put a thumbs up, a thumbs down. Do we even have a thumbs down? No, we don't. Okay, would you put a decimal at the end to make it 3 fig or 3 sig figs? Oh yeah, good question. Yes, we do put a decimal. The reason why, it's because if we just put 360, then that's 2 sig figs. Good one. Okay. So if everybody's feeling good about this, we'll move on to the next one. Next one is molecules. So we kind of touched on it a little bit. Just the bottom one here, it won't go up. So now we are converting from mass to molecules. So now they're asking how many H2O molecules are in 68.00 grams sample of H2O. Now, I have been giving you the mass, right, for like time's sake, but now we're talking about H2O, right? Now this, you kind of have, you can't go to the periodic table and find the answer. Basically, you'll have to find hydrogen first, multiply by 2 because we have 2 hydrogens, and then add oxygen. So this is why I put the answer here. This is the whole H2O, but try to find the mass on your own as well, okay? Because on the exam, mass will not be provided. But other than that, the format is the same. Does anybody want to tell me how we go from mass to moles? So kind of like what I have been covering right here, what I just highlighted. Yeah, I can repeat it. So basically, for this one, we are just going from mass to molecules, right? How many H2O molecules are in 68.00 grams of H2O? So now they're asking for H2O. H2O is a whole molecule, right? We have hydrogen and then we have oxygen. In order for you to find the molar mass of that, you are going to need to do some addition and multiplication, right? So try to do it on your own and then see if you get the same answer. I got 18.0, blah, blah, blah. So see if you got that one, okay? And then I want you to first, before you start getting into how to solve the problem, I want you to tell me this, what I highlighted on the top here. So from atoms to mass, we go from atoms to moles to mass, right? So what are the steps to solve mass to molecules? What are the conversions? Mass to moles to atoms. So is it atoms? Are we trying to find atoms? You have the right concept down though. Yeah. Okay. So two things. So One person said mass to moles to molecules, which is right. So I'm going to write that here first, and then I'll go to the next one. So it's mass to moles to molecules. Thank you very much. Also, the one like where we put atoms in place of molecules, it is kind of correct if you think about it, because the number is the same, but instead of atoms, we just put molecules. That's the only difference, but I can go into more detail about that too. Okay, so I got 18.015 gram, but I didn't get the 28 on my calculator for the mass of H2O. Where are you getting 28 from? Oh, okay. Yeah, I understand. So you're saying that you didn't get this 28. I actually got these numbers from the internet. I didn't follow the periodic table because that was easier. But stick to what's on your periodic table from your class. You will get the same answer, but for the exam, for the purpose of this class, just go to your modules and find that periodic table and then follow that math. Yes, good question. Okay, so I'll give you 3 more minutes to do this, and then we'll come back and do it together. We're actually doing really good on time. I'm proud of us. Okay, how's everybody else doing with the problem? Okay, so we have a little different answer, but I don't have the answer yet, but I'll try to find it and see which one's right. 270. Okay, so we have slightly different answers, so we'll see which one is more correct, okay? So now let's try to find the answer. So we start with 68.00 grams of H2O. Like we said, we want to go from mass to moles. In order for us to do that, we are going to put 1 mole of H2O is 18.015. So I'm just going to put 18.015 because that's what's in your periodic table for this class, okay? So I'm just going to ignore 28. Now we are going to go from moles to molecules. So 1 mole of H2O is 6.02. Multiple stoichiometry can be like one of the hard concepts of in organic chemistry, but I believe in us. We will get through it. So now I have 2 more problems before we end the session. Let's see if we are able to go through both of them. So now this is slightly different. Okay, so we're going from mass to atoms. The format is the same, but the question is different. So now they're saying how many hydrogen atoms are in 68.00 grams of H2O? So they are saying we started with 68.00 grams of H2O, but now we want the atoms for just hydrogen. Okay, not the whole H2O molecule. So try to do it on your own and let's see if we can try to come to a consensus with the answer. So a little more complex, but we got this. Where can I find the mass chart? So there isn't like a mass chart, but the periodic table that is in your modules has all of the masses. So for H2O, what you're gonna have to do is first find H2O equals blah 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 multiplied by 2, and then oxygen equals to blah blah blah, and then you're going to add all of these. Okay, if that doesn't make sense, let me know. Okay, it does. Okay, okay, so we have one answer. I'm giving you 2 more minutes or 3 maybe at max. Okay. Okay, so we can try to work on it together and like let's see. I haven't solved it either, so maybe it will be trial and error. Okay, so how many hydrogen atoms are in 68.00 gram sample of H2O? So we're gonna go from a whole molecule, cut it apart. We're not gonna care about oxygen. We're just gonna care about hydrogen here, okay? So let's try it. So we have 68.00 grams of H2O, right? Actually, let's write the way we format it. So we are going to go from mass to moles to atoms, even though there is like a slight step here, but we'll not add it here. Okay, so we are gonna go from this to just the moles. So let's do this, 1 mole of H2O, and I'm going to put 18.015 grams. Now they want it only for hydrogen, right? So what I'm gonna do here is I'm gonna put 1 mole of H2O, but on top, I am going to put 2 moles of hydrogen. Is everybody clear on this one? This here. Okay. So is everybody clear on what I just did here? Okay. So from here on, I'm going to put 1 mole of hydrogen, just hydrogen, and then I'm going to put the Avogadro's number. It's atoms. Okay, and then I'm going to cancel things out. So grams of H2O, moles of H2O, moles of hydrogen, and then I'm going to just have hydrogen here. So before we get into calculation, does everybody get how I put this whole thing? Because we do have an extra step, which is this one. This is new for us. I can go a little more into detail if you're still not sure. So basically, we know, I'm going to write it here. So, give me a second. Okay, so I'll just explain it verbally. So we know that we have 1 mole of H2O, right? And then how many moles do we have of hydrogen? We have 2 hydrogen and then 1 oxygen. This is why I'm putting 2 moles of hydrogen, okay? So I'm taking out the oxygen, just referring to 2 moles of hydrogen because I have 2 hydrogens. If this question was asking for hydrogen, I would have just put 1 mole of oxygen. No, if this question was asking for oxygen, yeah, then I would have put only 1 mole of oxygen. So does this kind of make sense? Yes. Thank you. So now we're gonna put this whole thing into the calculator, okay? Now let's see which question is more correct. So we're gonna put 68.00 divided by 18.015, and then we're gonna multiply it with 2, and then we're gonna multiply it by parentheses 6.02 multiplied by 10 to the power of 23, parentheses closed, and I get 4.14465723 multiplied by 10 to the power of 24 atoms of hydrogen. So in the beginning, we started out with only 4 sig figs. Okay, wait. Sorry, my pencil is acting up again. Okay, so we started with 4 sig figs, so we're gonna put the answer in 4 sig figs as well. So we are going to cut it off between the second 4 and 6. Since 6 is a little bit bigger than 5, we are going to put the answer as 4.545 multiplied by 10 to the power of 24 atoms of hydrogen. So does anybody have any questions about this question? This was a little different from the other ones we have been doing. So we're just going to put 4, 5 multiplied by 10 to the power 24 atoms of hydrogen. Okay. So since we are actually done with time, so this is going to be your exit ticket, okay? Or like entry ticket for Wednesday. So we have the next question, which I prepared. It was ions to mass. So the question is, how many grams of CO2 contain 6.02 multiplied by 23 oxygen ions? So this is actually kind of same as the one we just did, but it is the opposite of what we are doing. So try to solve this problem on your own, and then on my next session on Wednesday, I will solve it with everybody. This will kind of be like our icebreaker maybe. So everybody, like, just write this problem down, take a screenshot, and then